Sqilah. Enhancing Careers. Chapter 2. Position on the Earth. Position on Earth. Great Circle. A great circle is a circle drawn on the surface of a sphere which has the center of the sphere as its origin. These circles are the largest that can be drawn on the sphere's surface. Represents the shortest distance between 2 points on a sphere, utilized for long-distance routes. If any 2 points are chosen on the Earth's surface, a great circle can be drawn connecting them. Normally, only one great circle can be drawn through any 2 points. The exception to this rule is that if the points were diametrically opposed, the North Pole and the South Pole, for example, then an infinite number of great circles may be drawn. The great circle joining 2 points has a long and a short path. The short path will always be the shortest possible distance on the Earth's surface between the 2 points. The vertices of a great circle are the most northerly and southerly points on that great circle. The properties of vertices are: the points are called antipodal. The vertices are diametrically opposed. The distance between the points is 10,800 nanometers. At the vertex, the direction of the great circle is 90 degrees, 270 degree forward. That the great circle will cross the equator at longitudes 90 degrees from the vertex longitude. Example 1. If the most northerly point is 73 degrees north 20 degree W, then what is its most southerly point? Answer: 73 degrees south 160 degrees east. Example 2. Where the vertex is 73 degrees north 20 degree W, the longitudes that the great circle will cut the equator are. Answer: 110 degrees west 70 degree E. Small circle. A small circle is a circle drawn on the surface of a sphere which does not have the center of the sphere as its origin. The equator. The equator is the great circle that cuts the Earth in half in an east-west direction. To the north of the equator is the northern hemisphere, to the south the southern hemisphere. The distance from the equator to the North Pole is the same as the distance from the equator to the South Pole. Meridians. A meridian is a semi-great circle that joins the poles. Each meridian runs in a north-south direction, cuts the equator at right angles, has an antimeridian. With its antimeridian forms the complete great circle. Parallels of latitude. The parallels of latitude run perpendicular to the meridians. The parallels of latitude are all small circles except the equator. Always run in an east-west direction. Cut the meridians at right angles. Rhumb line. A rhumb line is a regularly curved line on the surface of the Earth that cuts all meridians at the same angle. Facts of rhumb line are: only one rhumb line can be drawn through 2 points on the Earth's surface. Not a great circle with the exception of A. the meridians, B. the equator, C. all parallels of latitude are rhumb lines, D. the distance along a rhumb line is not the shortest distance between 2 points unless the rhumb line is a meridian or a great circle. The difference in distance between flying a rhumb line track and a great circle. It is greatest over long distances. It increases with latitude. The adjacent table shows the difference in the rhumb line and great circle distances along 60 degrees north departing from 1000 E. Normally, flights of less than 1,000 nautical miles are flown along a rhumb line. Long-haul flights are flown on Great Circle Line, which consists of many small rhumb lines between the points on the way. Angular measurement. The sexagesimal system is used for angular measurement. The sexagesimal system is a base 60 positional numeral system for counting and measuring. It divides units into 60 smaller units, primarily used for time and angles, with a full circle being 360. Key aspects and usage of this system are: timekeeping. The most common modern usage is dividing hours into 60 minutes and minutes into 60 seconds. Geometry/trigonometry. A full circle is with angles measured in degrees, minutes, and seconds. Geographical coordinates. Degrees are subdivided into 60 minutes, which are further divided into 60 seconds. Calculation. 60 is a highly composite number, divisible by 1, 2, 3, 4, 5, and 6, making it convenient for fractions. In navigation, north is 000 degree, east is 90 degree, south is 180 degrees, west is 270 degrees. Where a direction is given, it is convention to use 3 figures. For example, 90 degrees is reported as 90 degree. Angles are always measured in a clockwise direction from north. Position reference system. In air navigation, it is necessary to pinpoint the position of an aircraft accurately and unambiguously. For this purpose, the Cartesian system is the simplest and most effective in two-dimensional space. Thus, the Cartesian system is good for work on a flat plane. However, the Earth is a three-dimensional spheroid, and for position on the Earth, a different system that is similar to Cartesian system can be employed. Latitude and longitude. Latitude and longitude form a coordinate system used to pinpoint any location on Earth using degrees. Latitude measures position north/south of the equator, 0 degrees to 90 degrees N/S, while longitude measures position east/west of the prime meridian, 0 degrees to 180 degrees E/W. Coordinates are generally given as latitude, longitude, such as in decimal degrees. Latitude lines are parallel. Longitude lines intersect at the poles. Latitude parallels. These are the lines run east-west, parallel to the equator. They range from 0 degrees at the equator to 90 degrees north at the North Pole and south at the South Pole. Longitude meridians. These are the lines run north-south from pole to pole. The prime meridian, 0 degrees, passes through Greenwich, England, with measurements extending east and west. On the Earth, position is described using latitude and longitudes where the x-axis is the equator and is defined as 0 degrees latitude, and the y-axis is aligned to the Greenwich meridian, the prime meridian, and is 0 degrees longitude. The latitude is expressed as the arc along the meridian between the equator and that point. Latitude has values up to 90 degrees and is annotated with the hemisphere where the point is situated. Example 40 degrees, 25 N or 40 degrees, 25 S. The longitude of a point is the shorter angular distance between the prime meridian and the meridian passing through the point. Like latitude, longitude is expressed in degrees and minutes. It is annotated east and west depending whether the point lies east or west of the prime meridian. Longitude cannot be greater than 180 degrees west or 180 degrees east. These two longitudes are coincident, and the meridian is referred to as the Greenwich antimeridian. Example 165 degrees 35 W or 165 degrees 35 E. Position using latitude and longitude. Position on the Earth is always expressed as latitude first, then longitude. The lines that form the parallels of latitude and the meridians are called the graticule. By using the graticule, any position on the Earth can be determined. In the adjacent diagram, Dar es Salaam, 6 degrees 49 minutes south, 39 degrees 16 minutes east. Dodoma, 6 degrees 10 minutes south, 35 degrees 44 minutes east. Arusha, 3 degrees 22 minutes south, 36 degrees 41 minutes east. Let us now look at the concepts of difference in latitude and longitude. The difference in latitude refers to the angular distance between two points with different latitudes measured in degrees, minutes, and seconds. In other words, the difference in latitude refers to how far apart two points are in terms of latitude. For example, here we have 2 points with different latitudes, 70 degrees north and 50 degrees south. In this case, the difference in latitude would be 120 degrees. Now, in this other case, where the latitudes are 80 degrees north and 20 degrees north, the difference in latitude would be 60 degrees. Now, to calculate the difference in latitude, the latitudes must be added or subtracted depending on the case. If both points are in the same hemisphere, then the latitudes must be subtracted to obtain the difference in latitude. In this example, both points are in the northern hemisphere, so we subtract the latitudes and obtain a difference in latitude of 54 degrees. On the other hand, if the 2 points are in different hemispheres, then the latitudes must be added to obtain the difference in latitude. In this example, 1 point is in the northern hemisphere while the other is in the southern hemisphere. So we add the latitudes and obtain a difference in latitude of 84 degrees. With this being said, let's look at some examples. In this first case, we can see that both points are in the northern hemisphere. So we just subtract the latitudes and obtain a difference in latitude of 24 degrees. Now, in this second case, the points are in different hemispheres, so we just add the latitudes to obtain a difference in latitude of 44 degrees. Now, up to this point, we have only used degrees for the examples. Let's see how to do this operation with degrees and minutes. In this first case, since both points are in the same hemisphere, we just have to subtract the latitudes. However, subtracting 15 minus 30 can be difficult if done manually. So it is better to convert one of the degrees into minutes so that we now have 18 degrees in 75 minutes instead of 19 degrees in 15 minutes. This way the operation is much easier now, and we obtain a difference in latitude of 8 degrees and 45 minutes. Now in this second case, the points are located in different hemispheres, so we have to add the latitudes. In this case, we obtain 95 degrees and 67 minutes. However, to express it correctly, we need to convert 60 of those minutes to 1 degree, then obtaining a difference in latitude of 96 degrees and 7 minutes. Now having seen the difference in latitude, let's now look at the difference in longitude. The difference in longitude is defined as the angular distance between two points with different longitudes measured in degrees, minutes, and seconds. So it is basically the same as the difference in latitude, but now in terms of longitude. So here, for example, these 2 points have different longitudes, which are 70 degrees west and 10 degrees east. Here the difference in longitude would be 80 degrees. And in this other case, where the longitudes of the points are 90 degrees east and 50 degrees east, the difference in longitude would be 40 degrees. As with latitude, to obtain the difference in longitude, these must be added or subtracted depending on the case. If both points are in the same hemisphere, then the longitudes must be subtracted to obtain the difference in longitude. So in this example, since both points are in the eastern hemisphere, then we subtract the longitudes and obtain a difference in longitude of 60 degrees. On the other hand, if both points are in different hemispheres, the longitudes must be added. So in this case, we just add the longitudes and obtain a difference in longitude of 90 degrees. Let's now look at some examples using degrees and minutes. In this first case, both points are in the western hemisphere, so we have to subtract the longitudes. However, as we have already seen, subtracting 20 minus 30 can be difficult if done manually. So it is better to convert one of the degrees into 60 minutes so that we now have 67 degrees in 80 minutes instead of 68 degrees in 20 minutes. This way the operation is much easier, and we obtain a difference in longitude of 49 degrees in 50 minutes. Now in this other case, the points are located in different hemispheres, so we have to add the longitudes. Here we obtain a difference in longitude of 31 degrees and 69 minutes. However, to express it correctly, we must convert 60 of those minutes into 1 degree, so we get 32 degrees and 9 minutes. So having seen how to obtain the difference in latitude and longitude, let's look at how to convert it into distance. As we previously mentioned, the distance between 2 points on the Earth's surface can be measured in angular terms since it is a sphere. However, angular distances are not used for navigation purposes since other units of linear distance are used, such as nautical miles, kilometers, etc. So the question is, how can we convert degrees, minutes, and seconds of arc to nautical miles, kilometers, or meters? Well, to answer this, we must first analyze the dimensions of the Earth. In practical terms, we can assume that the Earth is a perfect sphere with a circumference of 40,000 kilometers. With this in mind, we can then say that if 360 degrees equals 40,000 kilometers, then each degree equals 111.11 kilometers. And as we know, each degree can be divided into 60 minutes. So then each minute equals 1.852 kilometers, and 1.852 kilometers is exactly 1 nautical mile. So then we can say that each minute of arc equals 1 nautical mile. However, as we will see later, this rule is not true in all cases. In fact, this rule only applies when both points are on the equator or on the same meridian, which are great circles. But let's see why. At the equator, the circumference of the Earth is 40,000 kilometers, as we said before, which means that here each minute of arc equals 1 nautical mile. However, if we move towards the poles, for example, at 60 degrees of latitude north or south, the circumference of the Earth at this point is only 20,000 kilometers, which means that here each minute of arc equals 0.5 nautical miles. And if we move further towards the poles, we will see that the circumference becomes smaller and smaller. This can be seen more clearly if we look at the Earth from one of its poles. As we can see here, the circumference of the parallels gets smaller and smaller as we approach the pole, so that the same angular distance in terms of degrees and minutes will be equivalent to a smaller linear distance in terms of nautical miles. In this order of ideas, if both points are on the equator, we just have to find the difference in longitude and convert it to nautical miles. Let's see an example. Here the latitude of both points is 0 degrees, which means that they are both on the equator. So to determine the difference in longitude, we just have to subtract the longitudes, obtaining 7 degrees as a result. Now, since each degree equals to 60 minutes, this means that the difference in longitude can be expressed as 420 minutes. And since at the equator each minute equals 1 nautical mile, this means that the linear distance between these points is 420 nautical miles. Now let's see another example, but now with degrees and minutes. In this case, these points are both at the equator. And since they are in different hemispheres, we have to add the longitudes to obtain the difference in longitude, which in this case is 44 degrees and 41 minutes. Now, since each degree equals to 60 minutes, if we convert 44 degrees to minutes, the result will be 2,640 minutes plus the remaining 41 minutes. This way, since each minute equals 1 nautical mile at the equator, the distance between both points is 2,681 nautical miles. Now, a similar procedure applies when both points are located on the same meridian. In this case, we just have to determine the difference in latitude and then convert it to nautical miles. Let's see an example. Here, as we can see, both points are on the same meridian, which is 15 degrees west. So to determine the difference in latitude, we just have to subtract the latitudes, obtaining 9 degrees as a result. Now, if we convert 9 degrees to minutes, the result will be 540 minutes. And since on the same meridian 1 minute equals 1 nautical mile, this means that the distance between these points is 540 nautical miles. Let's now look at another example, but using degrees and minutes. In this case, both points are on the same meridian, which is 41 degrees and 39 minutes west. To obtain the difference in longitude, we just have to add them, which results in 15 degrees and 15 minutes. This way, if we convert 15 degrees to minutes, we obtain 900 minutes plus the remaining 15 minutes, which means that the distance between both points is 915 nautical miles. Now, so far we have seen the simplest cases where the rule of 1 minute equals 1 nautical mile can be applied. However, if what we want is to calculate the distance between 2 points independently of their latitude or longitude, we can do it by means of a more complex formula known as the Haversine formula, which is this one. What this formula does is to create a fictitious great circle that passes through the 2 points we are interested in, allowing us to determine the shortest distance between those points. One important thing to bear in mind is that the latitudes and longitudes must be converted to radians to introduce them in the formula. Let's see an example of how to use it. Suppose we want to determine the distance between these points. So here we have the corresponding latitudes and longitudes. However, in order to convert them to radians, it is necessary to change the sign according to the hemisphere. In this case, the northern and eastern hemispheres are positive, while the southern and western are negative. After doing this, we can now convert them to radians using this formula. Once this is done, we can now replace them in the formula and do the math, obtaining as a result a distance of 2,827.7 nautical miles.